Okay, so two guys called Niels, both working in Dataminded at some point, who wrote one, data engineering is not software engineering, and the other one, some version of data engineering is software engineering. Although to be fair to Niels, he was not so extreme, but we're going to ignore that for the sake of good story, okay? So, why is this? Okay. And every time I hear that, I get really annoyed, you know? Like, and for a while, I was thinking, why I'm so annoyed with this discussion? And then I realized the problem is because this discussion is actually the symptom of the great divide between data scientists and data engineers, okay? And yeah, I said data scientists and data engineers, not data engineers and software engineers. And this is why, because data engineers are usually the ones who are saying data engineering is software engineering, and data scientists are the ones who are saying data engineering is not software engineering. And I'm somebody who works as both data scientist and data engineer. So most of the time, I feel like a child of divorced parents, you know, trying to make them talk to each other. So this is me sitting my parents down and talking to them, because we need to destroy this wall. And how are we going to do that? Well, according to great philosopher Aretha Franklin, with just a little bit of respect, okay? So, what is this going to be about? I'm going to go over some list of common points of dispute. We're going to say, I'm going to start with like, this is what you should do. Then I'm going to present both sides of the discussion, why I want to solve it this way, and finally, we are going to say, hey, where still the original rule should hold. And behind the scene, we're actually going to talk about data engineering point of view and data scientist point of view, why are good software practices important, and how they're different in data science, or how should they be different in data science. And we're also going to mention some practices which need to be improved, and some rule which needs to be adjusted. So, first one. Trigger warning. I'm going to make exaggerated claims just for the sake of drama, okay? So deal with it. So the first one. Okay, so do not rely on unit tests to test your data, okay? So before you freak out, rely. I said rely, I never said don't write unit tests, okay? And why is this? Okay, what I'm doing wrong here? Can somebody please tell me? Okay, so and I'm using unit test as umbrella term for contract text, integration test, also different libraries like PyTest. So anything which tests only, which does not test data, just the code. And this is your hint why I don't think we should rely on unit tests, because they don't test data, just the code. And normally what happens when we have a data engineer working, and data engineers, they usually come from software engineering, so have this test-driven coding. And what they're going to do, they're going to take requirements, they're going to think, hey, what are the side cases? And then they need some automatic way to check on those side cases, so they're going to write unit test. Then they write the functions, and then they debug until the test passes. And then after that, we have data scientists. So they're going to analyze their data, because all the requirements they have are in the data, okay? And then they don't really need way to automatize, because the examples are already in the data, so just run it against the data. And then when it's working, looks good, okay, I'm done. And then data engineer head explodes. And why data engineer head explodes? Because they now need to put that code in production. And this code needs to work for days and months and years. And every time they change something, they can't go back and do all the manual testing data scientists originally did. It's just not feasible, it's too time, and they don't know how to do it, because they have to go through the whole process data scientist went through to when he was developing the code. So this is just not going to work. But this is not what data engineer is going to say to data scientist. It's going to say, this is not how it's done, okay? You need to write unit tests. And then data scientist is going to comply. Thank you. And it's going to start writing unit tests, but it's going to write way too many unit tests. And they're going to be too elaborated. They're going to be these huge tables in too many columns and too many rows. And they're going to be super exhausted of writing all that. And then after all of that, they're going to run the code, and the code will break. Because most codes will break in contact with data. And they're going to say, OK, this is too difficult, and it's also not so useful because my code is still not perfectly running. They're going to go to the data engineer and say, hey, this is hard. And data engineer is going to say, what are you talking about? Unit tests are not hard. And at this point, data scientists will just stop writing unit tests, and the wall is bigger, OK? Not even bomb can go through this wall. I saw this happening quite a few times. And let's stop now. And how are we going to do that? So there are two things which they need to understand in this discussion. First one, data scientists. So pipelines need to run for years. Manual testing is just not feasible, OK? And there is a skill in running unit tests. They're still often not trivial and always tedious. But if you write it correctly, it can be way, way easier. And for data engineers, code breaks in interaction with the data, OK? Unit tests are not testing data. Manual test data scientist will test data. And the real problem here is not that they didn't write unit tests. They didn't write automatic tests, OK? So what do we need to do here? So first, what we can do, test on data, as Jelle elaborated quite a bit. Data quality is a big issue. So before we even start our pipeline, we should write some codes which are going to test the data which is coming in. What can you test? Are there nulls? Is it unique? The columns which need to be unique. Are there duplicates? Join keys. Is the table empty? This is very important in my group. We always write this code, this test. Does input parameters make sense? Like the start date should be before end date. Then more elaborated things like what are about the outliers, you know? Is the distribution Gaussian? Like in a lot of machine learning models, you need Gaussian distribution. Okay, so all of this you can test after. And then after that, we can have, in my group, we call it smoke tests. And this is the test you do. So you have test on data before, then you run the code, and then you have a test after you run of your code. And you can do a lot of similar things, like are there nulls, unique, and so on. But you can also compare the input and output, because often you're going to have, for example, the sum of this column should maintain, OK? So you can check after that. And they're very versatile, because they can catch both problems with the data and with the code, you know? And sometimes they're tricky to write, because you need to have a good idea what to do. But once you have a good idea, it's super short to write. Usually it's like aggregate this column, whatever, and check if the aggregate is the same. And then they're just going to alert you of so many problems. How can you come up with this good idea? So first, you're going to do your manual testing in the beginning. This is a very important part of the early development. And then just kind of notice what kind of things you are checking, you know? Is there like total revenue needs to be maintained, for example? Is the number of rows correct? You know, like you can sometimes figure out how many rows there should be in the final table. Travel times, are they positive? You know, things like that. And then you automate those tests. So you basically write the function which are going to run afterwards. And you pick the best ones, because also this test, they run on the data, and data is big. So you don't want to be exaggerate with this tests and do something which is just overkill, you know? So pick the best ones and run those. And then finally, while this run in production, there will be new data quality issues, and this test will catch them. And you need to make sure there is a system which is going to alert you and also give you some kind of message which is going to make it easy for you to find where the problem is, okay? And then, yeah, this test, DBT, we're going to hear all about DBT and competitive. They are actually also already in, so singular tests and generic tests are actually doing things I was just talking about. And then finally, what is the third thing we need to do? Anybody knows? What? What, real data? No, this is real. This is all on real data. So this is, we run tests on the real data, then our code, and then a smoke test. What can we do finally? Write the unit test. Okay? So at the end, we still need to write unit tests. And why? Why is that? There are a couple of reasons. First, as a documentation, like sometimes maybe not clear what the function does, but in your unit test, you have a simple example of before and after, and it's easy to clear what kind of transformation is going on. Second, document the data quality issue, because you have to write the functions in many elaborated ways to deal with data quality issues that might not be clear from just the code, and the next programmer will be like, this could have been simpler. So if you go to unit test, you see what kind of data quality issue they're running, and then you can see what's going on. And finally, maintainability. It does not test data, but it still tests the logic of your code. So it is useful for that. Okay. The next one. Use notebooks in production. So I hear this a lot from data engineers, and it's like, oh, those lame data scientists, they use notebooks. Oh, so lame. Okay? Yeah, okay. We need to stop doing that, okay? Notebooks have their place, and their place is in early development, in exploration. In this code, it's super important that you have this fast feedback cycle. You don't want to deploy and wait like 30 minutes for something to run for you to see if, is there nulls in this column or whatever, You want to do that quickly, okay? And in the notebooks, you can do very quickly. Then you're going to spend a lot of time staring at your data. You want to have some kind of nice display. And you also want to have some easy visualization so you can notice the trends with your data and kind of what's going on, okay? So notebooks should be used, obligatory to use them in early exploration. However, not in production, okay? Once that is over, all this should be packed in nice little functions and moved in the code base. Okay? And this should be done by data scientists themselves, not the data engineer, because data engineer doesn't know your code, and it's very likely they're going to mess up something once they're transferring things. It should be done by data scientists. Hopefully, data engineer will provide the template and guidance of how to do it, but the data scientists themselves should do it. Third, make production data available in other environments. So this is me going to data architects and say, can I please have production data? And they're going to say no. So inspired by a real story. And if you Google and you're like, can I put production data put in my test environment? It's going to be no everywhere, So I was like, okay, I can't read all of this, so I'm just going to ask somebody to sum it up for me. So I asked ChatGPT, and says no, production data should not be available. Full stop, no discussion, okay? So I was like, okay, I'm going to take these rules and I'll see what's going on there. So what is the biggest reason they say this is not a good idea? And it's basically security and data leaks. So what they propose, you have one big production environment, only a couple very selected people can enter there. And then you have a test environment, which is like full of holes and everybody can enter and super insecure. And then, of course, you don't want to put your private data, sensitive data there, so they're kind of leaked through that. And what should you have in test? So these are the proposals. First is anonymized data, synthetic data, or sample data. Okay, sounds reasonable, except information you're looking for is in none of that data, okay? And as a data scientist, your job is to get information out of the data. And if your data doesn't have it, how are you going to do your job? On top of that, anonymous data, they're not that safe. This is like in 1997, so Latanaya Sweeney, she made this research. They took some medical data, which was anonymized and made publicly available. And then she managed to figure out 87% of people using only birthday, gender, and zip code. 87% of people are uniquely identified in their data set. So you should not so easily put anonymized data, in an unsafe environment, okay? Even if you anonymize them. So you can say, okay, we can remove gender, we can remove birthday, we can remove all the information, okay? So if you start doing that, there is less and less data project you can do with that data, okay? So if you're going to anonymize data, you have to anonymize it specifically for certain product. So if I'm going to make a model of this, I need to make sure that this anonymized data still has this information, okay? And we can't, and even then, we should never put it publicly. Synthetic data. So synthetic data is like fake data, which has all the properties as original data. So this is not super easy to kind of do, because you have to do a lot of analysis to know what your data properties has to make synthetic data, which will replicate them correctly. So one question, who is going to do that? Well, the person who is going to do that is probably the same data scientist which is going to do the model. So why don't you just give them the data directly, okay? If you're going to give them access anyway to make this synthetic data, just give them access. Why have all this extra work? And then sample data, okay, we can just do the sample. Okay, so, but what kind of sample? Do we just take random rows? What I have a timetable data, and each row is one stop on the way of the train. By taking randomly, I lose half of the stops of my trains, Or you can say, okay, I'm just going to take full trains. But which trains? What is representative, What if all my trains are in Brussels, So depending on what kind of problem you're having, different sample data is appropriate. However, even when you have very nice sample, there's still going to be data quality issue which is not going to be prepared that. And once you run your code on production data, poof, it's going to break, okay? So none of this is very ideal if you actually want to make a model. And then our dear data architects are going to say, hey, but what about security? It's very important. Security is very important. Well, the thing is, data platform should not be one big monolith, okay? What I showed before with big production and leaky tech, it shouldn't be like that. And actually, it's not. This is very much the thing of the past, okay? Nobody organizes their data nowadays, and they shouldn't, Johnny talked about it yesterday quite a bit, but what should we do here? So basically, you should have some kind of purpose-based accesses, okay? You should make sure that the people who have access to data have it for a reason. So only people who really need access have access, only while they're working on that project, and so on, okay? If you need help doing that, Data Product Portal, yeah, it's there, so we can help you with that. Next thing, we can have the same security in the test and production environment. There's no reason for test environment to be all this leaky thing everybody is accessing. You can make test environment, again, per purpose, per project. And finally, if you have some sensitive data, for example, when we work with HR data or customer data, HR will never even give me the real data. Anything I get is going to be anonymized. But then, this anonymized data should be anonymized for my project, and I want the same data in production, because I don't know how the shape of data is changed. What if there are they remove some columns and then drop duplicates, and there are actually way less column or rows in the my anonymized data than original data. Once in running production, it's not going to work. So I need to know, I can guarantee that it's running on data I have. I can't guarantee my code will work on the data which I don't have. So I want exactly the same data in production. I don't want it to be different. And then after that, if the data need to be de-anonymized for purpose, that can be done by HR themselves. So I pass them that, and they de-anonymize it after. Okay, so those are 3 big points. Now we have 3 small points. Don't use object-oriented programming for transformation. Object-oriented programming is super popular with software developers, especially with the Java background, and then they try to squeeze it everywhere. Except it doesn't really fit here. Okay? So why? Basically, it's this thing, immutability and stateless operations, okay? This is why we should use functional programming. So what's functional programming? You remember we write little functions, so we have everything nice and modular, as Jelle was also telling us before, nice little modules, and then we call them one by one after, and there are no difference in state inside. Like you give them some input, you get some output. So what is mutability? So mutable, it can be changed after creation, and immutable, it can't be changed after creation. So our data frames, they're immutable. Okay, what does that mean and why? So if you work with data, often you need to use distributed computing. So you're going to have your driver, and it's going to have multiple workers where it's going to send the data, the calculations happen, and then they get it back. So if you have something that's changing state, you don't know what's happening on different nodes. It can be changed to one state here, another one state here, another one there, then you collect it. So this is not really, but you know, it's very risky to have a lot of bugs, and the behavior is not predictable. That's why all data frames are immutable, and object-oriented programming is not good for it. However, this is when we're talking about transformations. There are more things you're going to do in your codex which is not transformation. For example, you need to connect to the storage account. This is quite useful to use object-oriented programming, because then you can abstract all the things like what is the actual path to container, what is the database, what's going on here. This you don't care about. You can abstract all of that, and you can also make it easy to do CI/CD. You go from different projects, different environments. You know, this also make it easy, but not for transformation. Okay, so now we're having two things which are very common advice, but I always see it done very, very wrong. First one is commenting the code. So what I see often, you have some kind of convoluted logic, and then you have a comment which kind of barely explains more than the name of the function itself. And it's like, okay, well, who is this useful for, you know? And even if the comment has more information than number of functions, it's just like a lazy way to cover up for convoluted code. So what we are going to do here, step one, do not write comments, okay? Everybody always told you write comments. I'm telling you, do not write comments. So remove your comments and deal with your logic. So everything I wrote before was very easy. It was just filtering the column. Okay, so deal with your logic. Now, what we want to do, we want to improve the names because they're filtering energy. You don't know why, what happened. So filter unrealistically large energy. Okay, this is telling us something. We are also going to put the types here, so we know what is input, what is output, helps with debugging, very cool. And then we're going to hardcode the column here, because this threshold is going to be only on this column. And we don't want to risk, it's more clear this way, we don't want to risk people running this on another energy column, like regenerated energy or some other, okay? And then finally, is there something else we didn't explain here? Yeah, 1,000, it's a magic number. Now we write comment, okay? And for the sake of my colleague Jos, it's going to be docstring. So, yeah, this is the magic number, and this we can't deal with in the code. So here we are going to explain where is this magic number coming from, why is this threshold, and where we can find more information. Next thing, keep things simple, stupid. Again, super common advice. We hear it all the time, and yet everybody ignores it. By the end, they kind of deal with their code. So here we have some code. Looks cool, you know, there is like a class definition, a lot of decorators, comments. Cool, huh? Except all this is doing exactly the same thing. So you have the constant for the weather station, then you set the standard, then you use this as a decorator in this one. By the way, this is impossible, so it's doing exactly the same. And why would anybody do that? Well, probably they wanted to kind of make it more flexible, so in the future, we are going to use multiple weather stations. And when the train is moving around the country, we are going dynamically to change which weather station to use. Except, hey, Belgium is not such a big country, okay? The weather is not so different. And implementing this on, you have trains, and as they move, you need to change states. We already discussed, very bad idea to change states when you deal with data. So this is quite difficult to implement. And the impact, is there going to be an impact? We don't really know. So this is very deeply in not worth doing category here. Super unlikely we're ever going to do it. So absolutely useless to spend any time doing it like that. So please always go and remember, whatever you do, it's not about using fancy tools or whatever. It's about having very clean code. And writing clean, simple code is way more difficult than writing elaborated long code, okay? And it takes way more time. And actually, you know, like, I'm more impressed when somebody sends me a code and I understand everything than when somebody sends me code and it's super long and I need to spend hours figuring out what it's doing. So keep things simple. So we are wrapping up. Hey, I'm on time. So, what are the software engineering best practices? So let's look at some of them. So we want to have modular code. We don't want to repeat ourselves. Want to have everything tested, version control, having different environments, and documenting, okay? And here I would add some more. It's time that we add to these practices. And there are two things about data. So first is properly managing our data. And this is data governance, data contract Jelle was talking about. And the second thing is having easy access to this data, easy visualization, quick feedback, okay? And this should be added to the general rules here. And now let's see what we were talking about. So we were talking about automatic testing, so not unit testing, automatic testing. We were talking about use notebooks and exploration, don't use them in production. Make production available in a test. Okay, I don't know what's going on. Don't use all object-oriented programming for transformations. And your code is your best documentation. And the most important lesson, keep things simple, stupid. So finally, it's how we can put our data scientist and our data engineer all together. So for data scientists, learn best practices. There is a reason why these practices are out there, why they're developed. Learn, but also don't learn just what, learn why and how to properly do it. On the other side, for data engineer, teach, don't preach, okay? Try to understand what is the data scientist using, what they need, introduce things one at a time, and be like educator, not somebody who is like, oh, you don't know how to use best practices. For data scientists, get interested in production. If you want to know, if you want to have a good relationship with your data engineer, you need to make sure you did everything possible to make their job easy, to make things your production. So I remember more than once I asked data scientists, don't you want to know what's happening in production? And they would be like, no. So yeah, get interested in that, because like, no matter how good your model is, how good results it does, if it never runs in production, it's useless, okay? And it's your job to make that easier for the rest. And on the other side, the data engineer, get interested in data. I also ask data engineers, like, don't you want to know what's in this data? And they say, no. So yeah, get interested in data, get interested in what people, how data scientists are working, what they're doing. This way you're going to be able to help them do their job the best and make the codes which are easy to put in production and to maintain for years. And finally, I want to put the rest, these two stories. Data engineering is software engineering, and data engineering is not software engineering. I hope soon enough I'm not going to hear about this anymore, because we're all going to get along super well and live in harmony. So thank you. So, questions? Yes?
So you work as both. Obviously, there will come the question: do you have a favorite role amongst the two?
Favorite what?
Yeah. Do you like the data engineering part or the data science part better?
Data science. I have to be honest. I kind of accidentally ended up here, so and then I kind of stayed. And yeah, data engineering I find very important, especially nowadays because, and especially when I started working here, because like then 87% of project was not going to production, so it was much worse. So data engineering is a very important part of work. I find it super important, but in my heart is data. I like to see what's in data. So, anything else? Yes?
So you compared software engineering to data engineering. So I'm posing this question because I'm changing my career track from a software developer towards data.
Mm-hmm.
So which role do you think would evolve in terms of tools and technologies faster in next 10 years?
Like which one? Like data engineer or science? The data
Software engineering
or data engineer?
Yes.
I don't know. You should ask those people who write a lot of blogs, and then sometimes they're right. And nobody knows, but I think the data engineering is definitely here to stay. It's a very growing thing. Like data is going to be important for a lot of time. Software engineering is also here to stay. I think both jobs are good. I think the most important is like what you like, what you enjoy, what kind of keeps you behind the computer. You know, is it something related to data, or is something more with, I don't know, APIs or web or games or I don't know what kind of things. What does software engineer actually do? I don't know. So something like that. So yeah, just do what you like. It's going to be fine. Yeah. Okay. Thank you. So I'm going to give my